go. Boom. All right. So quickly, we're going to go over this because the end of the 9 weeks is Friday. There's a quick turnaround. If you made below a 70 on the exam, and I think the cutoff was a 10 out of 20. 10 out of 20 is 50%, isn't it? 50% became a 70. So you got it right there. That's a 20-point curve. Ay, caramba. That's a lot. Why am I so generous? Why? I don't know. I mean, I could be hurting you. I don't think some of y'all want it badly enough. Some of y'all kind of have a casual approach. You're just kind of like, I'm going to come in here. I'm going to pay attention. Whatever gets in, gets in. I don't see a lot of sweat, blood, or even tears. I used to at least have tears. I had the starting quarterback several years ago crying in front of me in his football outfit because he failed a test and they needed him. Coach sent him to talk me into letting him play. I just let him cry in front of me. I mopped up the tears and I said, yo, bro, this class is exempt from no pass, no play. It doesn't matter. You're going to get to play anyway. He's like, really? Yeah. But anyway, after that, he shut down even more. Oh, because now he knew that it didn't matter. Oh, so that was back when I wasn't good at motivating people. Whatever. But he didn't want it. He wanted football, but he didn't want math. You have to want math. I can't make you want it. I can only entice you. I can send the mathematical aroma your way. Right? What?
I've never had a problem with math.
Good.
Unless I've been gone for like.
Let's go. Let's do this. We have something that is a quantity squared. Do we know how to square something? A quantity that's two terms? Did I tell you the little ditty? Remember the little ditty?
Square, add together.
No, that's what? Square what?
Square, add together. Square and add together. Double.
No, not add. And that's not a ditty. That doesn't flow. Square, multiply, double, square. Square, multiply, double, square. Square, multiply, double, square. Here's another ditty, right? Brill cream, a little dabble, do ya? That was for an old hair gel product. It's a ditty. All right, square, multiply, double, square. Square, multiply, double, square. Or you go off to the side and you write it side by side and you FOIL it out. I'm going to do square, multiply, double, square because you know what? This is a freaking honors class. And should you be able to square, multiply, double, square? Yeah, absolutely. Absolutely. When you square 3 over x squared, you square the top and you square the bottom. What is 3 squared? 9. That's the first line. What is x squared squared? X to the 4th. Boom. Good morning. Okay, so that's my first term. Now, to get the middle term, here you go, Jim. Oops. To get the middle term, we're going to multiply those. Now, I did that in my head, but I'm going to let y'all see how it works, okay? Because that's where the errors can come in. When we multiply and double, I'm going to come over here and say middle term. We're going to go 3 over x squared times 2x to the 1/2. That multiplies them, and then we need to double, right? Multiply, double, multiply, double. Let's see what the number is going to be. 2 times 3 times 2, what's that going to be? 6 times 2 is 12. And then how do I combine this? This is x to the 1/2 in the top and x squared in the bottom. So I subtract exponents. What's 1/2 minus 2? We practiced this. 1/2 minus 2. 2 is how many halves? 4 halves, right? 2 is 4 over 2. Everyone agree? You multiply by 2 over 2. So 1/2 minus 4 halves is negative. If you need to go off to the side, right? This is what we're doing. X to the 1/2 divided by x squared. That's x to the 1/2 minus 2. And then 1/2 minus 2 is the same as 2 over 2. Boom. Which is 1/2 minus 4 halves. Look at all this. If you need to do all that just to get the exponent, is that legal? Heck yeah. Get the right answer first. Find a way. Have the will, find the way, and then you got to work on being efficient. Okay? 1/2 minus 2. You multiply 2 by 2 over 2 because the denominator is 2. You get 4 halves. 1/2 minus 4 halves is negative 3 halves. So that's how I get my middle term right here. Multiply, double. There it is. And then you square. When you square 2 square root of x, you've got to square both factors. So what is 2 squared? 4. What is the square root of x squared? X, right? So that's how I got that first line. Square, multiply, double, square. Now, if you want, again, go off to the side and write them side by side and FOIL, that would work too. Watch, you would write it as 3x to the negative second plus 2x to the 1/2. That would be getting rid of your denominator x's and your radical x's. Yeah, bring it to the top. And then you just write it again. 3x to the negative second plus 2x to the 1/2. And now you could do FOIL. Okay. I'm not going to show you that method, but it does work. I would prefer y'all get on board with the square multiply double square, square multiply double square, square multiply double square. All right, and then all we got to do is clean it up. The first term and the last term are good. It's just that middle term. The negative will bring it to the bottom. So now it's 12 over. And because the denominator and the exponent is 2, remember that's the root. Roots grow underground in the denominator. So it's the square root of x cubed, not the cube root of x squared, which is answer choice D. So the answer is B, as in, boy, that was fun. Okay. It's choice B. I made this test while I was watching Monday Night Football. So I was inspired by the Ravens. Any comments or questions on that? Get it done, right? When you retest tomorrow, you won't have answer choices. So you'll have to get there on your own, show all the work. All right, number 2, F is that, G is that. What's the domain of? F of G, F of G. Well, the first thing we have to do is create H of X or F of G. You can call it H of X or F of G. Get in the habit of labeling your expressions if they have a name. You can call this function either H of X or F of G of X or both, okay? So F of G of X. G is on the inside, right? G is on the inside. You can see G sitting right there on the inside. So if you go to the F function is 1 over input plus 2. 1 over input plus 2. What are we going to plug in for the input? G of X. So there it is. It's 1 over not X plus 2, but it's 1 over G of X plus 2. And I just substituted G of X to be the square root of X minus 3. So that's the first step. Oh, sorry. Big old size 14s. Mr. Garnsey didn't have 14s, but I couldn't fit into smaller shoes this morning. I'm going to go ahead and put that line up above if you want. It's 1 over G of X plus 2, and then you replace G of X with what it is, right? G of X almost sounds like Giovanni, almost, right? Giovanni. I'm going to come up with a function, Giovanni. There you go. Nice. All right, now we got it set up. Guess what we get to do next? Find the domain. There's a square root. So I didn't show it, but X minus 3 has to be greater than or equal to 0, right? I did that out actually over here. Here's the radicand, right? Radicand. X minus 3 has to be greater than or equal, so X has to be greater than or equal to 3. Boom. And then what part of the denominator can't be 0? The entire freaking thing. That's right, all of it. Now, you could actually set it up and stop. You could stop right there when you set it up, because look, you have a positive radical plus another positive number. Something that's positive plus another positive number, is that ever going to be 0? I have something plus I have something. Does that mean you got nothing? No. Because these are both positive terms, it's never going to be 0. So if you want to go all the way through, it's fine. But when you check, it's going to be extraneous. Now, if that had been minus 2 to start with, then it's like, a positive number making it smaller could be 0. But anyway, if you were going to solve it, you have to isolate the radical term. So you bring the negative 2 across, square both sides, you get X equals 7, or can equal 7. But look, when you plug it in, 7 minus 3 is 4. Square root of 4 is 2. 2 plus 2 is 4. Yeah, 4 is not 0, so it's extraneous, which means it doesn't cause a 0, which means you don't need to throw them out, which means the domain is just what? Greater than or equal to 3. And that's answer choice A. Yeah. Comments or questions on that? All right, number 3, simplify. If you're still missing these complex fraction problems, you need to come in the mornings and visit me in tutorials, okay? I gave it to you kind of hybrid. There's 2 negative exponents in the numerator, but we have 2 fractions already set up in the denominator. So your first step is to get rid of the negative 3 and negative 2 and put them in bunk beds, right? So that was my first step. In the top left, it's 3x squared in the top, and y to the negative third comes to the bottom of that term only, right? Bunk beds, remember, upstairs, downstairs. Minus, we're still upstairs. X to the negative second goes downstairs. Now we have 5y squared over x squared. The bottom you just rewrite, okay? So that was just a little bit of housekeeping, right? Upstairs. Now we look for the LCM. We have factors of x and y. We take the largest exponent on each factor. We have an x squared and we have a y cubed. So x squared y cubed is the LCM. All right. Now I didn't put them over one, but I have an upstairs LCM and a downstairs LCM. If you want to put them over one to help yourself, then man, that's fine. So this will be over one. When you distribute now, things will divide out by design. So always do your division first. You're destroying those bunk beds, right? And this is pretty easy. Look, your y cubes divide out on the first one, and you're left with 3x squared times x squared, which is 3x to the fourth. At this point on a multiple choice, you could already start eliminating answer choices. If that's not a 3x to the fourth in the front, you can like, nope, sorry. On a retest though, you have to keep going. If you distribute to the next one, look, both the x squareds are gone. That's easy. So you're just left with 5y squared y cubed, which is 5y to the what? What's y squared times y cubed? Is it y to the fifth or y to the sixth? The fifth. Right. And then in the bottom, your x squareds divide out, and you're left with 2y times y cubed, which is 2y to the fourth. And then here's the hardest one. Only one of the y's divides out. So we're left with the y squared. Everything else is gone completely. So we get 4x to the fifth, y squared. And that's your bottom. Okay. It's like four separate problems, right? Distribute. Top left, top right, bottom left, bottom right. And then we talked about how if you wanted to, you could physically write the LCM 4 times behind each of the 4 factors so that you can, or you can multiply straight across, write it down, and then divide out. But being able to do it in your head, that's kind of what honor students should be able to do. So push yourself a little bit, right? You can manufacture the desire. I know you can. Go talk to Mr. Kilford. I think what they say, fake it until you make it. All right. Once you start understanding it and making a little progress because you're pushing yourself a little bit, then it starts to get, dare I say, fun. And then you want to do more, right? Fun easy. It's fun easy. Okay. So get out of your comfort zone. That's where the growth occurs. All right, number 4, Brady, here we go. What interval gives you the solution to that? Hey, I just threw at you a quadratic inequality. You don't have to set it up from a radical or anything. Now, I know it's a parabola that opens down, right? It's negative x squared. It's a parabola that opens down. Hey, can you solve quadratic inequalities algebraically? Not just no, but Hades no, right? Hades no. So I'm going to graph it. I need to find the roots. In order to find the roots, we need to F it, right? F it. The first rule of factoring is to pull out a common factor. But if you have a negative leading coefficient, you can factor it out first. That's what I did. Okay, factor out the negative, parentheses, it changes all the signs. Now, I leave the negative in place. We talked about in class how you can multiply both sides by the negative to get rid of it, but then it would do what with your inequality? Flip it. I'm going to keep it like this and just say it opens down, and I want to know where it's positive. That's above. It opens down, and I want to know where it's positive. That's above. Hey, just a second. If it opens down like a frown, and I want to know where it's positive, is it going to be between the x-intercepts or outside the x-intercepts? Between. It's like we're staring at the Gateway Arch right there on the banks of East St. Louis behind us, looking out over the west. It's going to be between. Look at your answer choices. You know it's got to be A, D, or E then. Those are the only 2 that are between. Now, what's the difference? Can you factor correctly? Factors of negative 30 that add up to positive 1. Negative 30 and positive 1. It's going to be a positive 6 and a negative 5 on the factoring. X plus 6, X minus 5. Therefore, the roots of the zeros are negative 6 and positive 5. Oh, now that we have those, you really don't even need to sketch the graph if you show me the roots. But I went ahead and sketched the graph, and now I highlighted where the y values are positive, and there you go. It's strictly between, so negative 6 to 5. I put graph on the free response, and a lot of people didn't even put graph. Yes, sir, 3 bags full. Nope. No, if you wrote it in inequality notation, remember, this is what I said in class. Here are your solutions right here. Those are the X values that work, right? You could think of those shaded regions as the X values that work. Look how it's physically situated there. A -6, an X, and a 5. And now they're just going to be less thans. When it's the AND case, the connected interval, it's always less thans or less than or equal to's. Okay? Always. That's between. Yeah, that's a great question. Thank you for bringing that up. What you can't do, and people are still doing this, and I think this is why I'm having health problems this year. People are saying X plus 6 is greater than 0, and X minus 5 is greater than 0. Therefore, X is greater than -6, and X is greater than 5. And I have no idea what I'm doing, and I don't really care, and I haven't been in tutorials, and I'm just coasting. You're still in pandemic mode. Got to get out of that, right? We got to shake off the lack of rigor that's been happening the last year and a half. And that was kind of by necessity, right? But we're all back, and I get up every morning to help you. So you got to help yourself, okay? So yeah, don't do that. Don't do that. This is a no, 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 no. All right, which of the following are equivalent? This was like halftime, I think, of this of the game, and I'm like, you know what? I need one more question because we're only going to do 5 of these because I was going to put more questions on the free response. So I knew I needed one more question, and I had written like 2 or 3 of them during the second quarter. Like, no, I don't like those. I don't like those. So I looked at some old tests and like, you know, we did them a couple of times on some old tests. Conjugate over conjugate. We did that quite a bit, didn't we? Right? Conjugate over conjugate. And I'm like, I'm going to craft a question that has to do with conjugate over conjugate. And we're just going to see if they can figure it out. They're smart enough. We've done it in the past, right? It's like I show you how to use a saw, and we practice sawing boards with the saw, and then I walk away and I give you a board and I just say, hey, can you make this shorter? And you're like, oh, how do I make it shorter? We never practiced making a board shorter. All we practiced was sawing wood. But you're like, hey, you know what? When I sawed that board, it made it shorter. So I'm just going to use the same skill that he taught me when we were practicing cutting. Now to make it shorter, all I got to do is cut that board. I know. Because that's like me telling you make the board shorter and you don't know how. You don't know what to do with the board and the saw. We've done it in isolation, but problem solving is putting your skills together to solve bigger problems. You have resources, you have skills, and you got to figure out. The first thing is to figure out what the question is asking. Which of the following are equivalent? These are all numerical expressions, aren't they? There's no variables. Now, if you had a calculator, it'd be a piece of cake, right? In fact, it would be a worthless question if you had a calculator, because then all you got to do is plug them in. Get the decimal, get the decimal, get the decimal. And if they're the same, it's like, thank you, calculator. But what are you learning? Nothing. You know you can use the calculator. We want to practice problem solving. 1/2 plus the square root of 3 and 2 minus the square root of 3. Let's look at the third one first. Let's look at the third one, because the third one is giving me something obvious that I can do. I have a quantity squared, a binomial squared. Hey, do you remember what we did on the very first problem on this test? Square, multiply, double square. Square, multiply, double square. Square, multiply, double square. Okay, let's try that. When you square the square root of 2, you get 2. Now, when you multiply and double, you're going to get plus 2 times the square root of 2 times the 4th root of 3. I don't know what that is yet, but that's multiplying those two and doubling, and it's going to be negative actually, right? Because one of them is negative. So that's your middle term, right? Middle term, not middle finger. Don't have that bad attitude. It's the middle term. And now when you square the last, a negative number squared is positive, and you're going to end up with the 4th root squared. Sure. What's the 4th root squared? Well, let's think about it this way. The 4th root of 3 is the same as 3 to the 1/4. Yes, yes. And now when I square that, I do that. Everyone agree? Okay, so that looks ugly. That looks really ugly. Square, multiply, double, square. Let's see if we can simplify that. That's going to be 2, and then you're going to have minus the middle term. I'm just going to put MT because that's gross. When you raise a power to a power, what do you do with the exponents when you raise a power to a power? You multiply. What's 2 times a fourth? 1/2. You get 3 to the 1/2. So you're going to end up with 2 minus some gross middle term plus the square root of 3. Hey, is that going to be equal to number 2? They kind of look the same, right? Oh, it's close though, isn't it? Except the one that I have has this gross middle term, which is obviously not 0, right? And if it were, it would still be plus the square root of 3, not minus the square root of 3. So it's not equal to 2. So I know that 2 and 3 are not equal to each other. So anything that has a 2 and a 3 in it now is what? Out. Out. So I guess I got to compare 1 and 2. Well, let's take a look at 1 over 2 plus the square root of 3 versus, right, like it's a competition, 2 minus the square root of 3 over 1. Man, this is where you have to say, I learned how to saw. Now can I make a board shorter? The first one has a radical on the bottom. The second one has a radical on the top. Did we learn a method for getting a radical out of the top or the bottom? Yeah, it's called what? That process is called, starts with an R and rhymes with rationalization. Rationalization. Can a word rhyme with itself? I guess technically. Rationalization. Now, because it's 2 terms, we can't just multiply by square root of 3 over square root of 3. We have to multiply by the conjugate. Conjugate over the conjugate. Muy bien. So let's just do this one over here. Okay, I'm gonna switch flavors. Actually, I did it right here. Look right there. I multiply by 2 minus root 3 over 2 minus root 3. In the top, 1 times 2 minus root 3 is 2 minus root 3. That's what we have in the new numerator. And look what happens in the denominator. Oh, this is beautiful. 2 times 2 is 4. Look what happens on the inner and outer again. Plus 2 square root of 3 on the inside, minus 2 square root of 3 on the outside. They're gone. And then look what we have on the end. A positive times a negative is a negative. And a square root of 3 times the square root of 3 is a 3. What's 4 minus 3? 1. What's anything divided by 1? It's self. So guess what this ends up being? 2 minus the square root of 3. Hey, are those equal then? So it's not a competition. It's not versus. In fact, it's equal. So 1 and 2 are equal to each other. Holy moly smokers. What a fantastic question. Thank you, halftime. Thank you, halftime. Right? It's not like I don't like listening to Chris Collinsworth, or they go back to the studio, I think. They're equal. All right. Comments or questions on the multiple choice? If you show up for a retest, what I'll probably have you do on number 5 is have you do a conjugation, and that's it. Okay, because on number 1, we've already square multiply double squared. So I'll probably just give you like something like Roman numeral 1, and I'll say rationalize this expression if you show up for the retest. And you do it by multiplying by the conjugate over the conjugate. Piece of what? If you like cake, and cake's easy, right? It could be like a piece of a Skittle or a piece of a pizza, right? Piece of cheese, right? Whatever you think is easy, it's a piece of that. There you go. My dogs love cheese too. All right. Here's the one that I put on there that I was like, this is like free point. It's like me handing out like dollar bills to everybody. Here you go. Free money, free money. We went over this. I didn't count off for spelling unless you egregiously misspelled it. Like you misspelled infinite, P-O-I-N-T. Then I took off. Okay. Right. Yes. No, it is non-removable. Yes, you're right. See, this was halftime was ending. The game was starting. And when I was making my key, I didn't even put it in there. But yeah, thank you. I didn't grade it that way. I knew it was non-removable. So I was expecting you to have that. Thank you, though, for pointing that out. Yeah. So removable point, those are the 2 words I needed to see. If you didn't say discontinuity, I didn't take off because I was telling you they're discontinuities. But it was nice to have it in there. A removable point discontinuity. If you had anything else, like removable discontinuity, so close. Point discontinuity, so close. And then this one was a non-removable infinite discontinuity. And the words I was looking for were non-removable, hyphenated or non-hyphenated, and infinite. Okay. A lot of people had N-I-N-F-I-N-A-T-E, infinite. I didn't count off for that. Some people put non-removable infinity discontinuity, and I'm like, yeah, it's close enough. You got the idea. Okay, infinity, right? I was dressed like Woody that day, maybe, so maybe you are thinking Buzz Lightyear. I don't know. But yeah, those were, I told you that you can call it a hole and you can call it a VA as long as you knew the formal names. And I think I heard everybody in here at least once call it a hole and a VA. But you can't call them by their nickname until you know their name, right? Yeah. Free money. There you go. Boom. All right. Now we're setting it up. R is F times G. F times G. Well, let's see. F is a two-term dude. G is a two-term dude. I thought this would be a piece of cake, especially after going over the last test. Notice again, it says set up the, what's that word? Set up the equine. Is that a horse? Equation. Oh, so I better have like an equal sign and two sides. Is that that? C. So I'm telling you the name. The name is Roger of X. So R of X equals, get that out of the way. If you didn't do that on any of them, whether I said equation or not, you lost 1 point. There was 1 point total for notation, which is being generous, because in the second semester, when the expectations are there and y'all are well trained, if you lose notation at any point, it's going to be a doc each time, because now you're lying. If you don't have the right notation, you're lying mathematically. Mathematical prevarication is a sin. Say what you mean and mean what you say. Don't lie with words or with math. Okay? Be very deliberate. Now, we need parentheses, don't we, in the top around these two factors, F and G, don't we? Yes. If you didn't have parentheses there, but you put a dot between the negative 2x and the x, that's not correct, because now you're multiplying those two terms, and now you have a 4-term dude. Who's your best friend in this class? Parentheses, right? They're like this, baby. Jump in. My arms are cradled, ready to catch you. Jump. It's better to have me and not need me and deal with the awkwardness than to need me, Michael, and not have me. Yeah. All right. So that's all I wanted. Set up the equation. This part, free response, was like the 4 questions that y'all did in my absence, right? Yeah. Boom. Check right there. Escape. Do you need parentheses around the bottom? No. Is it okay to have those two terms in parentheses? Yes. Yes. But you don't need them there because that's just one function. All right. Part B, write it in factored form. R of X equals. If you don't have R of X or R equals, you lost that notation check. But you didn't lose it more than once. So you can mess up on notation once you lose it once forever, and you're not going to get docked again right on now in this test. So what's the first rule of factoring? Go to Wolfram Alpha. Pull out a common factor. Look at that first factor. It's already factored in the top, but can it be factored more? Yeah, the top one has a common factor of X, which leaves you 3x minus 2. That's a prime linear factor now, x to the first. That's a prime linear factor, x to the first. And x minus 7 is a prime linear factor. We talked about those. So that's all you had to do in the top. Some people were trying to factor 3x squared minus 2x with like 2 binomials and something real creative. If you would have tried it out by foiling it, you would have realized it didn't work. And then the bottom, I did 2 steps in one, just because I can do that. But if you pull out an x in the bottom, you're left with x squared minus 49, yes? X squared minus 49 is a difference of 2 perfect squares. And a difference of 2 perfect squares factors into the product of 2 what? Conjugates. So x plus 7, x minus 7, or flipped around. This is the factored form. Notice I didn't do any. A lot of people did. And as long as I can see what was underneath there, some people were dangerously close to obscuring the view. That's all I wanted, factor form. R of X equals, boom, primo. Number 2, second check. All right, now, I asked the questions in the correct order. Before you simplify and get rid of the X factors and the X minus 7 factors, before you do that, you have to find the domain. There are 3 values of X that give you division by 0. There's no square root here, but there are 3 values of X that give you division by 0. What are they? 0, -7, +7. So you can just sit over there, Irene, taking. So D colon or D sub R colon, I don't care. D colon or D sub R colon. That's part of the notation. Okay. So if you missed that, you lost a check. I just did set notation because it's easy. The set of all X such that X cannot equal, and now I'm listing X values. So in any order, 0, -7, 7. Check, check, check. Check, check, check. Okay. Now, if you wanted to do that in interval notation, knock yourself out. It's a little bit more work because now you got to go from least to greatest. D colon or D sub R colon X epsilon. I didn't count off if you didn't put X epsilon, but that would be preferred. -infinity to -7, step over the cow patty. -7 to 0, step over the cow patty. 7, step over the cow patty, cruise. Okay. Parentheses everywhere. Either one of those. Check, check, check. All right. So good so far? So far, so good? Yeah. How are we doing on time? Plenty of time? Oh, we've got 14 minutes. We're making good time.
I realize every step.
Okay. You know, when you yawn, some people find that offensive because it's like, oh, I'm bored, but that's not true. You know what a yawn is? A yawn is oxygenating your brain. When you yawn, you're oxygenating your brain. It's actually a compliment. It's like, I'm getting into this. I'm powering up, sir, to infinity and maybe a little bit past it. No. Yeah. You don't want to go overboard.
+1.
To infinity +1. Yeah. Oh. All right. Okay. Hey, what do you call a lawyer when he's cooking dinner? A sous chef. All right. Letter D. Letter D. Write R of X in simplified form. Call this form Y. Okay. Simplified form just means divide out the factors. What two factors divide out? X and X -7. So I was looking for Y equals, or even R of X equals. I didn't count off because that's technically true. And that was a check. All right. That was the 6th check. Now, I did not count off if you didn't put, and I missed it here, X cannot equal. I didn't count off. But remember, it's preferred if you then say, hey, the equation in simplified form does not permit you to use a -7. That's a non-removable factor. That's going to be a vertical asymptote. But 0 and 7 are now allowable. The function really does not exist there. So warn people, be nice, say, hey, there's a wormhole right there. You don't want to step in it. You'll like end up in Venus or something. Hey, don't go to 7. There's a wormhole. If you fall in there, you're going to end up in Uranus, right? You don't want to end up in Uranus, okay? So, my daughter's like elementary school teacher when they were learning the planet. She didn't have the courage to call the planet by its name, so she made up a name for it. She called it Uranus. And I'm like, nope, it's Uranus. Just call it what it is. All right. Comments, questions so far? That's like calling Pluto Plato. Plato. What? Write the coordinates, coordinates. See how coordinates is in bold? And then I even put X, Y for each and every hole. The two factors that went away were X and X -7. Therefore, the two roots, 0 and 7, are the locations of the holes. Okay. I didn't take off if you didn't show the work, but I do like you for indicating your method. Y of 0, plug it into Y, you get -2/7. Y of 7, you're going to get 19/14. Those are the two Y values that used to be there that are now gone. And now we answer the question. So R has holes, plural, at the coordinate 0, -2/7, and 7, 19/14. If you just had the two ordered pairs there, I gave you credit. I just assumed that if you came up with -2/7 and 19/14, you plugged it into the right thing. But it's nice to always indicate your method. All right. That was a check apiece. That was a check apiece. Now, if you had the wrong equation here because you factored it wrong, I did work the problem with you based upon your equation. So like if you had X -7 up there still, you would expect to have a hole at X equals -7. And then I looked to see what your value should have been. So I did work it with you and try to give you points back on parts E and F up to a maximum of 3. Okay. What are the equations of every vertical asymptote? Write none if it has none. Well, what's the non-removable factor? X plus 7. What's its corresponding root? -7. But you can't just say -7 because it's a vertical asymptote. It's a line, and so it's X equals -7. If you just put X equals -7, that's the 9th check. A lot of people put X equals 7. And then I looked up top to see if they had X minus 7 left. And no, they had X plus 7. And they just put 7. So remember, you're looking at the root, the value of X that makes it 0. It's the opposite sign of what the factor has. Okay. If you put like X equals -7 and at X equals 0, and you already lost the check up there for not including 0 as a whole, I didn't double whammy you. It was only worth so many points. So I'm not going to generate more points just to penalize you more. So as long as you had X equals -7, if you had like 5 other, I think also at X equals 2 and X equals 37, and there might be one at X equals 100. I just like drew a line through that if I already took off up here. These 2 parts alone were only worth 3 points. Okay. So you never would lose more than 3. Does that make sense? Okay. And you're never going to gain more than 3 either. And then extra credit. I threw these out there. I thought they'd be easy. What are the x-intercepts? That's the root of the function, right? The root of the function is you come back up to the simplified form. The root is the value that makes the whole thing 0. If you set the whole fraction equal to 0, we said a fraction is equal to 0 when the numerator is 0. So what's the only value of x now after you divide out any wholes that makes the numerator 0? 2/3. That's the x value. So the coordinate would be 2/3, comma 0. It's the value that makes the numerator 0. 2/3, comma 0. Okay. If you wanted to show it, you would take the numerator of the simplified form and set it equal to 0. 3x minus 2 equals 0. X equals 2/3. Okay. That was worth, I put +1 or +2 at the top, but it was worth 2 points. We decided that each of these were worth 2 points. So there was an additional 4 points you could have earned. All right. The test itself was worth 105. One person in my class made a perfect score, only one in Miss Lincoln's class. So that person becomes automatically every time a 101. That's right. And then if you got both bonus, that's an additional 4, so 105. That person did not make a 105. All right, now, is there a y-intercept? How do you find y-intercepts? Any point on the y-axis is going to have an x-coordinate of what? 0. Y'all did that all through Algebra 1. You did that all through Algebra 2. Y-intercepts are the easier ones to find. X-intercepts, they're hard to find generally because you have to factor. Y-intercepts are easy, right? What's the y value when x is 0? That's going to land you, well, what do we know about x equals 0? Is there a y value there? There's a hole there, right? So none. There's a hole there. Okay. R has a hole at x equals 0. Okay, so that was worth another 2 points. So if you got any of these right at the top, you'll see like additionally +1 or +2. And then when I calculated the score, you'll see me say like +2 and I drew an arrow, or +4 and I drew an arrow. Okay. And then finally, the last one. I thought this would be easy. Set up L of x, so it's the 4th root, or it's 4 times. It's actually 4 times. See how it's outside the crotch right there? Now, here's the thing. Whether you thought it was 4 times the square root or the 4th root was irrelevant, because either way, they're both even roots. Only one person asked me, is that the 4th root? Is that 4 times? So it's supposed to be 4 times the square root. But it doesn't matter because all I'm asking you for is the domain. And if it's a 4th root, that's an even root. If it's a square root, that's an even root. So it works out to be exactly the same. So it didn't affect the answer. Okay. But in general, if you have a question about anything during the test, I'm sitting over here, I'm walking around, just raise your hand. Okay. I'm taking the radicand, 3x squared minus 2x, and I'm saying it's greater than or equal to 0. And then I'm taking the entire denominator, x minus 7, and I'm saying it can equal 0. Well, let's do the denominator first. That's an easy one, right? X can equal 7. If I saw x can equal 7 anywhere, Unless you gave a final answer that excluded x equals 7, you got to check. Because when you put it in set notation, if you don't put it in there, you're telling me that you considered it and then realized that it didn't affect the answer. But it does. X can't be 7. Now, look at this. 3x squared minus 2x. That's a quadratic. Can we solve it algebraically? Hades? No. Hades, no. Okay? But I do know it's a parabola that opens what? Up. It's positive 3. If I could find the roots, I'll know the x values where it crosses. How do we find x-intercepts? They're harder than y-intercepts. Y-intercepts, you just plug in a 0 for x. But for x-intercepts, you have to F it, right? What's the first rule of factoring? Common factor. Pull out an x, you're left with 3x minus 2. It's factored. Do not, some people still did this. This is where my heart goes. X is greater than or equal to 0, and 3x minus 2 is greater than or equal to 0. If you do that, make sure off to the side you say, hey, Mr. Corby, this is supposed to be funny. Ha ha, funny, right? Not like funny, weird. And then I'm like, oh, you're making a joke. Good one, because it doesn't work. But what are the two roots? I put roots. X equals 0, x equals 2/3. If you need to go off to the side and set them both equal to 0, that's fine. But you don't set them both greater than or equal to 0. Now, what do you do with those? Look, it says show the work or show the graph that leads to your answer. So many people did not sketch a graph and got the wrong answer. And that's why, okay? You couldn't just sketch any old parabola. I needed to see the roots. I needed to see 0 and 2/3, okay? So 0, 2/3, those are the dots, it opens up. I want to know where it's greater than or equal to 0. So that's going to be here. That's going to be above. So is that outside or between my x-intercepts? Outside of. Now, can I include 0 and 2/3? Are they open circles or solid dots? Solid, because they're in the numerator. Now, if you shade to the left and shade to the right, it's good. But what about 7? Remember that gives us division by 0? So we have to step over it. See that? So there, I'm staring at a graph of my solution set. So if you want to do it as an interval, it would be from negative infinity, parentheses, up to 0 bracket, union, bracket 2/3, up to 7, parentheses, step over it, union, parentheses 7 to infinity. Or if you wanted to do it in an interval, set of all x such that x is less than or equal to 0, greater than or equal to 2/3, comma, as long as you don't choose 7. So the interval for the outside the x-intercepts was worth 1 check. Some people only had x is less than or equal to 0. Some people only had x is greater than or equal to 2/3. Those are the people that try to solve it algebraically. You can't do it. Quit doing that. And then 7 as a final answer, stated, not just considered, but stated as a final answer was your 12th check. Now, 13th check was for any type of notation. Missing function name at any point. If you put a colon instead of an equal, if you put an equal instead of a colon, if you left off a colon, if you left off an equal sign, if you forgot your braces, et cetera, et cetera, et cetera. I only did that 1 point total. So 13 checks on that one, 2 checks on the bottom of the front. That's 15 plus 5 multiple choice questions. That came out to be a 20-point test. All right. We did. We got it all in one class. Hopefully, if you made a mistake, you caught it, you found it. Let me know if I made a mistake. I'll give you points back. All right. When is the retest? Tomorrow morning. The end of the 9 weeks is Friday. The retest is tomorrow morning. If you need to retest and you can't make it tomorrow morning, let me know. We'll come up with a substitute. I am here when the doors open. Someone came at 7:30. They got in somehow. I don't know if they crawled through the sewer and came up in one of the bathrooms, but they got in before the doors open. I'm here at 7:30. Doors open at 7:45. Come see me. We can talk about it before you test, but give yourself at least 50 minutes to test, okay? Nice shirt, Chris. All right. Have a great day.